Hi, my name is Dr. Miriam Goldstein, and I am currently the Managing Director of Energy and Environment and the Director of Ocean Policy at the Center for American Progress, which is a think tank in Washington, D.C., where we try to promote good progressive policy in the federal government. The C-Plex Voyage took place in the summer of 2009, and the purpose was to try to understand what had become known as the Great Pacific Garbage Patch. But not very much at that time was really known scientifically about what was out there. So we were leaving the dock to try to figure out how much plastic there was and what it was doing to ocean life way out there in the middle of the ocean. On this voyage, I was the chief scientist, so I was in charge of all of the operations and logistics and getting all the science done. And I also had my own research, which was trying to figure out how much plastic there was on the surface, for which I worked both with my own work with plankton nets and with one of the folks on the ship named Andrew Titmus, who was doing visual counts, but with binoculars. And I also was trying to figure out what animals were living attached to the plastic and what, if anything, the plastic was doing to their lives. How would you describe a 24-hour day for you while working on the New Horizon in the Pacific Gyre? Well, I describe it as about 21 hours of work because we were constantly sampling, and also as chief scientist, I had additional duties around what everyone else was doing and making sure the schedule stayed on track and adapting it to local conditions. So I might be doing my own sampling, processing my samples, helping other people sample or work on deck, talking with the captain about how we were going to move the ship around to conduct all these operations. Of course, doing a little bit of eating. You eat about 5 times a day when you're at sea. And in general, just tracking our progress to make sure that we could achieve all of the many goals that we had for this trip. So it was an enormous preparation. We had to come up with the whole plan for what the ship was going to do. That was my job as chief scientist, to actually come up with a schedule for what happens every single hour after we leave the dock. And we had that schedule ahead of time, although of course we had to adapt it to conditions and changes, because the ship also operates 24/7. So you have a schedule for every hour of every day. So then you leave the dock and you kick into your schedule because you have already planned that out. And there's a trade-off between stopping to sample and getting underway to where you're going. So we left the dock and we had planned essentially a shakedown just a little ways off San Diego, so we could all learn how to deploy the equipment and know who should do what and who should haul on what line and how to be safe on deck, which is really important because there's very heavy equipment flying around and safety is the most important thing. Before the trip, the thing about going to sea is you have to bring everything you need on the boat. And if you forget it, that's too bad. I often dream about forgetting all my socks, only having one pair for like a 3-week or a month voyage. But in terms of the science, we had to think about every single piece of equipment that we would need, every chemical, every tool, every Sharpie marker, and make sure that we packed everything. And we had to be prepared for different conditions because we did not know what we were going to find or if the weather would be good or if we'd even find plastic. So we made lots of lists of equipment, and we then had to go borrow the equipment because we were students. We didn't actually own any of this. So we then had to go ask other people if we could borrow their nets and CTDs, which is an oceanographic tool, and all of this that didn't come with the ship, chemicals to preserve the samples, everything. So all of that logistics needs to be happening. And even things like making sure that everyone who has food restrictions, that the galley knows. So for example, if there's vegetarians or people who can't eat certain foods that need to be accommodated. How did you manage to store a sample from one net pull before the next net pull came up? Well, 2 reasons. One, with help. We worked as a team and there was a lot of teamwork. So everyone helped contribute, and maybe one person would actually be conducting the net pull and the other person would be processing the sample. 2, it does take like a while for the net to actually go through the water. So you have, I think about half an hour is what we did to actually process the previous sample. So you have to move quickly. So those 2 powers combined mean that we got everything done.